Hey guys, welcome to our final presentation about our FYDP project, a Chrome extension for time analysis and management tool. And you can find the download link of our Chrome extension in the description sections. First things first, now let's have a quick demo about our product.
So for the pop-up of our extension, the home page essentially showcases the different time that we've spent for the websites today. So it's only one day. For the time rule feature, we can essentially add the time that we want to limit ourselves. So let's say if I want to limit myself to 1 minute of Google each day, I would simply add it. And you can see I've already spent 6 minutes on Google. And in terms of iString feature, essentially this lets us define how much time that we want to spend consecutive browsing until a notification pops up saying that we should take a break. And now let's take a look at the dashboard.
Okay, so the dashboard page is actually the default entry point of the entire option page, which gives you the very detailed overview about the browsing activity for current day or in the past days, like a different visualization for the data that this extension collected. As you can see a chart. You can select the type of chart on the left to drop down, and you can select the date for the duration, etc. And at the below, there are some raw data displayed for additional references. And in order to manipulate the data in more detail, for example, exporting or just viewing those data in more raw format, you can just enter the export options for that feature.
So here's our page for export options page. And here user will be able to customize what data they want to export through selecting different columns, filters, what density. And finally click on export. They will be able to get the CSV file and they can do whatever they want with the data. Now moving on to the other two features we mentioned before.
So for the restriction rule setting, so we will set a time limit for a specific domain such that there will be a pop-up when it reaches time limit. As for the next feature, we have the exclusion list where we will not track any of the activities in this particular domain for the user if they want to avoid this being in their records.
We're going to start looking at the requirements and specification. We believe that our opportunity lies in the fact that computer users are increasingly using the browser for their personal interest as well as daily work, and past survey statistics have shown this trend. Our goal is to build an all-in-one Chrome extension that has all the necessary features to maintain good routines. We found that all the current competitive products are either too simple or too complicated such that it takes a great deal of effort to understand how to use. We think that if a user cannot understand how it works within 30 seconds of navigation, then it's not user-friendly. So we thought we have the opportunity here to make a product that is both feature-packed and easy to use. We have gone through the following software engineering process. First, understand requirements and perform analysis. Second, create Figma design and write product specification. Third, build prototype and acquire user feedback. And finally, finalizing the product and released it on Chrome Web Store. And we followed agile development throughout. Moving on to design, implementation, and deployment. We're going to take a look at the overview first. So we have broken down the extension architecture into 3 sections: storage, background, and front end. The data storage utilizes Google Chrome's own local storage API to store data in JSON format. The background script in turn contains time detection algorithm and all the feature logic, so it's the fundamental core to our software. Then we have front end, where we use React and MUI library to construct visual appealing extension pop-up and homepage. Aside from that, we have the content script, which is responsible for injecting custom HTML into a web page's DOM, and this script is utilized by us to create notification dialog in the browser tab that the user is currently focused on. And our extension only monitors the time usage of those meaningful websites that are either HTTP or HTTPS encrypted, or those that are not inside the user's exclusion list. Our background script communicates with the frontend and content script through Chrome-provided messaging API and an event callback. The main language we've used for the project is TypeScript, as we think it's better for development, readability, and has static error checking. And we have a total of 3,982 lines of code, which are mostly TypeScript with a few files of CSV, JSON, JavaScript, HTML, and CSS.
Okay, thank you, Sean, for talking about the general overview, and now we move on to our data design. First of all, I will introduce you our data schema. All the data stored in our storage is in the form of key-value pairs. So to support the main feature mentioned in the previous specification, we store three kinds of user data. The first one is domain data, which essentially records the daily time usage with a specific domain. This part of data is read-only. That means it can only be modified through our extension script, and no user interaction will change this part of the data. Then we have time root data. This is for user to get notifications when they have reached the specified maximum usage of the domain. User will be able to add, delete, or update this part of data in the settings page. And then there's also exclusion list data, which records all the domain that the user wants to exclude from the whole calculation. Other than those main part of data, we also have some metadata for customized settings. Snooze data is used when user choose to snooze their notification associated with the time rule. And iStream data contains a threshold time and a break time. So our extension would remind users to take a break when the threshold time is reached. The second key point of our data design is that we're using a local-only storage. So all the user data is stored on their own computer and there is no remote database or backups involved at all. The reason that we decided to go with this design is because, first, the overhead of using remote database is too much for an extension. As an extension that operates 24/7, we don't want to slow down or disrupt users' daily web routine. Another important reason is that using remote database would actually bypass the Chrome's protection and bring the data out of the sandbox. Since the data is very personal, we don't want to leave any security concerns on the user's end. But the downside of going with this choice is that our data storage is less flexible, since we'll only have 5 MB maximum for the Chrome extension storage. To better accommodate this downside, we have implemented a two-step rollup process to ensure that the user will always have space for the new data. In this rollup process, when the first time the data limit is reached, we aggregate the domain data for the oldest date. That will remove all the domain-specific data and replace it with only a daily total usage instead. Then, if all the domain data is already aggregated and the maximum limit is still reached, we will rotate out the oldest entry of the domain data. That is to permanently delete the time usage information on the oldest date. So that's all about our data design, and now we move on to our event-driven background system design. To accurately record users' time usage on the web, we have two layers of the underlying logic. The first one is event-driven. Whenever user switches tabs, or the computer starts idling, or when the user starts watching a video, an event will be triggered and the backend data will be updated accordingly. But only this is not enough, because for time rules, we also want to remind the user in time when they reach the maximum daily usage. Hence, we also implemented a timer polling process that polls every few seconds to detect the current active browser tab and add that time to the backend data accordingly, or triggers notification if needed. Then we move on to the MVC model that is used with the callback synchronization. This MVC model handles all the user interactions, hence the read-only domain data will not be included in this part of the discussion. For example, whenever a user wants to make a change on the settings page, they enter some information and then press the OK button to commit the change. Then the React layer would use some Chrome's messaging API to request specific dataset from the background. And then when the background receives such request, it would process it, fetch the requested data, or update any data as specified in the request. And after that, it will return to the callback function in the API call with the fetched data, if there is any, and a status code. Then, when the front-end service receives that data, it interprets the data, validates, and reflects the return information to the UI if there is no error in the return status code. Error messages will be displayed otherwise.
Okay, now I'm back to give an introduction about the data visualization work we've done for this project. So data fetching for visualization work is automatic, meaning it does not require the user interaction to complete. Well, sort of. If assuming users refreshing the page does not count. Therefore, unlike a full MVC about viewer controller pattern, it is a pretty much like a very simple client-server pattern from the top-level perspective, where the front-end controllers like React plus MUI message handlers will message background script through Chrome APIs to request data from backend, and the backend receives the message, directly fetch the data required, and then package the data as a response. Then this response will be invoked through a callback created and also sent through the message before. This callback created by the front-end controllers, so that the entire required fetch process is synchronized and sequential. After receiving the data, controllers will pre-process the data, like filtering, sorting, and mapping to fit specific visualization components. And finally, the data will be displayed in the front end. So the first part in the front end that mainly serves the visualization process is the UI components. And we use the Material UI for the implementation work, hence the MUI. The reason we chose MUI is because it is a modern, active project in community. It works great with React, which is a boilerplate of our front-end stuff. And most importantly, it has a very, very thorough documentation and consistent theming presets so that we do not have to worry about details too much to focus on core logic of this project. There is a catch when using MUI though, it is about refactoring and migrate. It's because there is a major version upgraded when we are actually under the way. But the process is we noticed a lot of changes that's already put in the main line of this of MUI. So we decided to do the migration work. But the change is so significant that even the family name of the package are different. But luckily, as I mentioned above, this is also well documented by the MUI community. So that actually compensated a lot of the hardness. And another thing regarding the MUI is just that it just does not work along with the React in the content injection work, because the team we thought this is relatively heavy for the injection work to be done. So as a workaround, we use the HTML plus CSS style injection for now to increase some certain level of to get some certain level of efficiency. But we indeed got inspired a lot from the MUI and its documentation, which gave many great insights. And the second part of visualization is Recharts, a third-party library for data charting. It is a boilerplate for charting data. It has a great start point to build a functional chart, but we thought that was not enough, so we customize our own chart on top of it using the APIs provided. Recharts uses JSXL to describe, meaning a chart, especially a customized one, can be trivially modularized, independently deployed, and used in our software architecture. That shows a very strong expandability for future work if we need to add new charts or views to current code base. And there's a very small bug we noticed when using recharts is that the animated transition can interfere other functionality of the chart if it gets interrupted. This only happens in the pie chart on the dashboard page. And when animation gets interrupted, the tooltips for each pie sector will not be visible anymore. So as a workaround, we currently disable that and continue the investigation.
Hi, I'm Haosen, and today we'll be talking about the API barriers and the deployment of our application. So for the API barrier, we use this term to guide how far we can implement our application with manifest version 3. So the barriers means that all the actions and data transactions must be implemented with only manifest v3 APIs, and we don't want to bypass the predefined functionalities and the scope of the sandbox, because what we have is that this kind of user usage data is extremely sensitive, and we don't want them to be exposed to anything that the users feel like they're uncomfortable with sharing with. So we try to limit our usage of the APIs as minimum as possible. And it's also something that we want to make sure that we can benefit from this kind of closure or limited usage of API usage, so that when, let's say, something gets exposed, then we can say this is not our fault, so that we make sure that our liability is minimized. And then we will talk about the deployment of applications. So first of all, our application or our Chrome extension is done with React, which means that it will have to be compiled into a JS package with Webpack, and then we upload our entire package with the assets and everything to Chrome Web Store, and we make sure that we compartmentalize our permission usage for Chrome extension. And also during that process, we realized that we are requiring APIs and permissions that we don't need, so we have to cut them down in the end. And also, so there are slight discrepancies between the design and implementation. We originally designed a reward system for the users to follow healthy routines, but it was not implemented because it was not something that we found to be attractive to the users. And the categorization is also not done completely because we realized that APIs would be very costly to implement. And then also we try to make sure that it's extendable for the future. And then there are interesting things that, like, for example, we use MUI version 4, and then we have to switch to version 5 because they updated it. So there was a little bit of technical debt that we had to resolve during that time. And then we make sure that we apply our fundamental design principles as well as possible. So for the verification and validation of our Chrome extension, it is a pretty unique process because, first of all, we usually validate the functionality of our product through the data usage, since we want to test the functionalities as we are using it, and also because it runs on the background a lot of times, so it's better that we use it daily to make sure that the functionality is actually correct. And also we stress test them for longer term time usage, and we collect those and then see if we can make improvements. And then we also have 4 different testing techniques we use. First of all is the unit testing, which is the most relevant technique to us. Our software ensures that the correctness of the functions that we use makes to make sure that the individual components that function properly. And then secondly, we also have integration testing, where we put all the components together to ensure that the features work together and the cooperation between the components actually work. And then we also have system testing, where we tested the product extensively through our daily usage to ensure that
we meet our usage requirement and user experience requirements that are hard to test for because they are not included in unit testing or integration testing. And then we also use user testing, where we conduct interview sessions with potential users and people we know, and also we have online reviews by the users. As you can see here, one of our users posted a review and the feedback that, can we make the break duration for the iStream tool slightly shorter.
So that's all about our presentation today, and thank you so much for watching. And we hope to see you all in the Q&A session.